Okay, well, listen, ladies and gentlemen, I think we should get underway. I would like to welcome you all for this presentation today on nuclear CHP possibilities in Canada. Combined heat and power is what that acronym stands for. And I might preface that Michael's presentation is part of a project, well, it's a core of a project that started, about 24 months ago in a presentation I gave to the Canadian Association, the Club of Rome, on the environmental polycrisis. I then at that time was calling it planetary limits. But as a result of that, Bob Walker, regular in some of the meetings that a number of us attend, approached me because he was very interested in that presentation. And we ended up talking about some aspect that we could do in Canada with respect to the climate change part of that poly crisis. And that led to a connection with the Boltzmann Institute. And that led to what you're now about to hear from one of our partners in that initiative, and that's Michael Wiggin. So I'd like to introduce Michael to you as an interesting gentleman. And today he's had a long history in what we call district heating, and today has a new term because district heating has been typically associated with things like a hospital campus or a university campus, or like here in Ottawa, the central heating plant of many of the buildings along Wellington Street and so on is heated by one facility. So that's a district heating, but thermal networks are really a new concept or a broader concept, not more new in North America than in Europe and elsewhere, where the networks are actually citywide. And so we have an opportunity here with this proposal that we're developing of taking heat from nuclear power facilities, which is just waste heat, goes into the air and into the water, and channeling that heat into pipes. And those pipes could come either certainly the right of ways and some aspects of the pipes, and Michael will probably talk more about this, with respect to heating through the natural gas companies. So it might be a transition opportunity for part of the fossil fuel, at least on the distribution side, to a new business model where they're selling heat rather than just a natural gas. So Michael has 36 years experience in this district heating business, and he is a member of the Boltzmann Institute, which he took on that position post his retirement from NRCan, where he was the director of district heating and cooling research and development. And he also took some time off between the government, NRCan and Boltzmann, and played an important role in developing the Green Municipal Fund, which is a project that is administered by the Federation of Canadian Municipalities. And some of us know David Waters, who was the Assistant Deputy Minister of Finance, who provided the funding for the Green Municipal Fund. So there's a connection in among our colleagues who participate in these various events that we get together, and one of them is Michael in his role in the Green Municipal Fund. So without further ado, I'll turn it over to Michael to take charge of the rest of this meeting. As you will recall, we're being recorded, and if you have any questions or comments, please post them in the chat. And if there's a burning question that or need to make a comment, and that might happen, like Martin, if you wish to interrupt, intercede, just raise your hand or put your hand up as the tool allows us to do. So, Michael, over to you.
Okay. Well, thank you very much for that introduction, Peter. First thing I'd mention, district heating is still the dominant term used throughout the world. You've got cities like Copenhagen, Helsinki, Stockholm, and many more that are about 98% buildings are served by district heating. But some of us started to use the term for Canada of thermal networks. The reason being is we had to get people to think beyond just projects. We had to get them think of thermal networks in the same way we think of electric networks, gas networks, water networks, and so forth. So getting them to move from as Peter was mentioning, the small project, central heating plant university, going beyond that. So this is critical, I think, is getting, because whenever you mention it to the provincial government, for example, they give you examples of small projects they're doing. That is not what we need. We need a major transformation in our energy systems. If we're going to get rid of gas, fossil fuel, then it's quite a challenge, and I'll discuss that. So, thermal networks just seem to be a term that might get people thinking on a larger scale. Um, so, now I'm going to talk about nuclear. I should point out that I'm not necessarily an advocate of nuclear per se, but the amount of energy wasted from nuclear plants is so large, and it can be captured with relatively minor modification at the design stage. So I'll focus on nuclear CHP because there's so much going on. But as I said in the subtitle, it's a catalyst for the thermal networks, catalyst for new energy systems that can use energy in many different ways. So um, again, I'm repeating myself a little bit, but I should just mention something. I was reading Bob Ray's book the other day, Exporting Democracy. It's about 2011. But he was saying if you want to get consensus um, between conflicting countries or groups within countries, you have to address each one of them and win the hearts and minds of the people. It's the same thing here. If we're going to see major transformations, we have to look at all the major stakeholders and win their hearts and minds, get their understanding so they feel comfortable and see value in some kind of shared direction we want to go in. But within the nuclear industry, and like the electric industry, it's very specialized, and people are working in a very focused way, designing and trying to make them more affordable, safer, or whatever, nuclear reactors. And they're in this model of generating electricity. And it's very, very, very hard to get them thinking otherwise. I've had some very senior colleagues, Peter knows some of them, that they said, I've been in this business 40 years and I never even heard of it or thought about it, about the connection between thermal networks and district heating. So I'm saying that not to say anybody's ignorant, but it's incredible what specialization does sometimes. It steers us away from integrated thinking. And I think with this group, Foresight, uh, it is imperative that we get much better at integrated thinking. Um, so some time ago, I started to focus on the nuclear industry and talk to people and try and figure out what makes them tick. How do we get them to think in a different way about what we're doing? So, what we're asking about the integration of electricity and thermal, including nuclear, CHP, these things are being done in other countries, but we have had such a wealth of energy, natural gas, and so forth, and we weren't really as serious as we should have been on greenhouse gas reduction, and we weren't that worried about security of supply. So we, quite frankly, have been kind of lazy. Chug along with what we're doing, and everybody was happy. So anyhow, I think um, there's a lot going on in the world now, and we could do the same. First of all, thermal network. Um, there's a lot more of it around than you'd think, but it's invisible. Once you construct it, it's buried and you never see it anymore. University of Ottawa has got a combination of steam and hot water, one of the more modern systems around on the hot water side. Uh, Ottawa is just refurbished totally. The whole district energy system serve government buildings, and they're looking at expanding to serve the rest of the community as a possibility. But anyhow, so you get the shallow buried insulated pipes. It's not like the old days where you put steam pipes in tunnels. You have pre-insulated pipes with high value polyurethane insulation, polyethylene jacket. You only need to bury them 600 millimeters meter underground for structural protection, and then you can start linking things together. Um, but before going on, I wanted to focus on the big issue. The big issue I think that we've got to confront is peak load management. If you have fossil fuel, the energy density is so high and the network's infrastructure set up that we've never really worried about it very much. Um, but heating is very different than general electricity. I'll give you some numbers later on. But if you take fossil fuel, oil, natural gas out of the equation, the challenge of meeting the peak load at the coldest day in the winter is really something. Um, and I'll come back to it, but not only is the peak high, but the utilization of the capacity to serve that peak is very, very low. So, uh, right now, everybody's talking, like all the nuclear guys I know, getting quite, oops, sorry, uh, I touched my screen in the wrong place. Yeah, anyhow, my nuclear colleagues, they were getting all very, very excited about the growth in the electricity industry and nuclear power to serve building heating. But what they didn't understand is the characteristics of that heating load, and it's completely at variance with what they would like to see for loads for nuclear. To demonstrate, um, what I've got here is my colleague Martin developed this work, is we got many years data of actual electricity loads in Ontario, and the lower blue line shows what the load looks like over a couple of years. Now you'll have winter peaks and you'll have summer peaks for cooling. They're not that far apart, but the utilization of the peak capacity is about 67%. That is, once you install enough capacity to meet the peak, you're going to use the equivalent of 67% of that output. Now, if you put the heating load, that's here in red, it's much more scattered and much higher. Like the peak heating load in Ontario is on natural gas now is about 70 gigawatts. The peak load for electricity is about 23. So if you're going to electrify, install the capacity to meet that peak, you got quite a problem on your hands. You're going to have to triple or quadruple the electricity capacity we have today. That took decades to build, and now we're saying we're going to do it by 2050. In our consultation with IESO, OPG, a lot of the local distribution companies, they're all trying to realize that this is not possible. Okay? Now, as I said, the current utilization of the electric system is about 67%. If you added on air source heat pumps to meet urban needs and ground source for less dense rural needs, that overall utilization has dropped to about 26%. But if you look at the heating by itself, it's even worse than that. So here, if you're not familiar with load duration curves, basically, if you go back to a load curve like I was showing you before for heating, if you divide that up in 1 hour sectors and rank it from highest to lowest, you'll get a curve that looks like the blue one there. So the peak, the 100% of peak load, is very, very short duration, but you got to meet it. You can't say, oh, we're not going to provide heating today. It's too high. Doesn't work. And overall, the year, the utilization is only about 25% of that peak capacity. Now, if you put in heat pumps, then right now, the peak is about the same. If you look at the electricity required for a heat pump compared to, let's say, electric resistance heating, they have a COP of 1 at peak load, roughly. And so you still have to meet the same peak, but because of the efficiency during much of the year, the utilization drops down to about 10%. So for the incremental capacity you're going to install in your electric system to serve building loads, if you were tell the electric industry they're going to install this capacity and they're only going to get 10% utilization, customers might like it, but it's terrible for the utilities. It's just a financial impossibility. So what happens if you were to see broad application of air source heat pumps, you might find that your electric rates might triple. Okay. And if you look at the IESO plan, their long-term outlook, they don't, they say, well, our job is to estimate what will happen, and our job is to meet it. But their estimate of what will happen is that only 7.6% of buildings will have heat pumps. What the other buildings do, well, that's their problem. So they're not really getting involved in the discussion with the political sector, with other technologies, about how we as a society are going to meet our heating loads in a decarbonized way. And they basically admitted in their outlook that electricity ain't the solution. They're not going to be able to do it. Okay, so hope that makes sense. I wanted to mention too before I went on is that because of this peak, and I showed you, if you look at the top, let's say 60% of the heating load on that load duration curve, it only ends up being about 15% of the annual energy. So if you could store those peaks, you could do a lot to minimize peaks and increase utilization. But if you want to store energy electrically, they're talking about batteries and other things, but it's very, very expensive. And they're talking about 2,000 megawatts of installed capacity as if it's a great thing. It sure is. But if your peak heating load is 70 gigawatts and the big peak you might want to reduce by storage is, let's say, 30 gigawatts, putting in 2,000 megawatts of heating is not, or electric storage isn't going to do the trick. So anyhow, but thermal storage, here's an example. There's many different kinds. Small storage might be like water tanks, insulated water tanks. They've got this in Markham District Heating. But now they're starting to see the value in seasonal storage. So in this instance, in Vanta, they're putting in underground caverns, about 1.1 million cubic meters of excavation. And it can store about 90 gigawatt hours of heat. That is enough to heat many small cities. Okay. I was doing some work with China, and they're doing one double that size, about 180 gigawatts. Okay. So if you had this capacity, 90 gigawatt hours is a long way from 2,000 megawatts you're talking about in Ontario. But if you can do this economically, and the price is quite economical, especially compared to electric, about 1% of the cost, then we could really go a long way on load management. And so the reason I wanted to bring this up is whatever technology we select, this load management issue will be a key challenge for us. Moving on, I'm sorry, on my screen, I've got the people are covering part of the thing, but again, Martin developed this. We analyzed the heat loads, the population densities, building energy densities in all of the provinces, and we came out with these S curves that show how the density increases as a percentage of population. And so about 70% of the buildings are in a density that's probably adequate to make district heating happen. To verify this, we had a leading district energy consultant look at some cities in Canada, picked one hypothetical one, and looked at all different energy densities and did the work to show what might be feasible to serve. So this isn't just conjured up out of a graph, it's based on real evidence of what's being done in Canada and other countries. So we established it may be possible to serve with district energy networks, thermal networks, about 70% of the buildings in Canada. And for those that are not dense enough for that, we might look at ground source heat pumps, solar thermal, and other ways of meeting the heating load. Now, coming back to nuclear, on the left-hand graph, uh, uh, we've got the current business model. The nuclear plants want to be base loaded. Uh, they want to do electricity only. So I took this example from a British study by Mott MacDonald. It might have about 500 megawatts of reactor output and about 175 megawatts of electric output. That's the current business model, and people are having a hard time moving out of that. However, without modifying the reactor part, you can change the steam turbine part so that it can generate rather right now you design your steam turbines so you can reject heat at the lowest possible temperature and maximize your electric output. But if you could imagine making that turbine a little bit shorter with a higher condensing temperature, you would lose some electricity, but the heat would now be much more useful. It might be, let's say, 100 degrees instead of 35 degrees. And the ratio of electricity lost to heat made useful, you're not making new heat, you're just making the existing heat more useful, making a bit more of it, is, let's say, about 8 or 10 to 1 at around 100 degrees, depending on the specific turbine. So without modifying the reactor, you could, uh, rather than having shorter or longer turbines, you put in extraction ports at different temperatures. And if you need one temperature, you take it out one port. If you need a higher temperature, take it somewhere else. And you can manipulate the temperature extraction to minimize electric losses. But basically, what I'm showing in business option two is instead of making all electricity like on the left, uh, part of the year you make heat to meet the heat load and you lose a bit of electricity, but then your production during the year, the 8,760 hours in the year, might look more like option two. Now, but that, even that is only making part use of part of the capacity. If you include thermal storage, then you can keep the reactor turbines putting out that heat at the required temperature constantly. And if the heat available is more than the load, you can put it into storage. And if the heat demanded is more than is available, you can take it from the steam turbines as well as from the thermal storage. So this is becoming, this is like the standard way current district heating systems work that have, coal, oil, gas, uh, or even biomass cogeneration plants or CHP plants. But it looks like that would be quite possible with nuclear reactors. If you're just playing with the steam turbine sector, while there's a lot of resistance, everybody says, no, no, you can't do that. We found more and more people once they opened up to it. They said, "Yeah, I can see that happening." And in fact, the Mott MacDonald report suggested that the cost to modify a plant with the proper extraction ports and space for heat exchangers and piping, the incremental cost, if you do it at the design stage, might be in the order of 0.2% of capital cost. So that means if we can get the attention of OPG and so forth working at Pickering, they could include the modifications to provide heat at a small incremental cost, even if you don't have the heat load yet. But once you've got that possibility, then the heat loads can be developed to hook up, even if it's 10 years from now. And other than that 0.2% investment or whatever it happens to be in Canada, you have the possibility of the future of using all or most of the heat from that to heat cities. Uh, Pickering, for example, could heat most of Toronto if it were designed the way in business case 3. Okay, so um, uh, we are getting people more open to it. We're discussing it more, and I'm working with groups including like Hatch, a big consultant for the nuclear industry, AECL, CNL, um, some of the leading consultants in district energy, and others on a value proposition. What is in it for us to change our business model, to transform our energy systems? So that's a big project we're going to undertake, and we want to do it quickly because decisions are being made right now in nuclear plants as we speak. And the longer we leave off this convincing argument, the more likely we'll be too late. Because after you fix the design decisions, it's not easy to go back and change it afterwards. Okay, so I hope that was a little bit clear. So um, this is urgent. As I said, decisions are being made, but and there's resistance. But the thing is that I should have mentioned if you had a CHP plant, nuclear CHP plant, and you price the heat to compensate for the loss in electricity, and the effective COP was somewhere around 8 or 10, that means if the nuclear plants are expecting to sell the electricity for $10, $100 a megawatt hour, they could sell the heat extracted for $10 a megawatt hour and break even. If they can sell the heat for more than $10, they can make more money. In fact, if you could sell heat for about $35 all year round, then they could double their revenues compared to electric only. Okay. And so this is really an important thing we're finding to get people on side. So while everybody's concerned, because I haven't looked at it, it looks like these are concerns that can be addressed. And if we, and I've just talked about varying the steam turbine section, increasingly some of the new generation reactors, they can vary the reactor output as well, much more flexibly than our early CANDU type reactors. So it may be that we'll find nuclear CHP could be coupled with thermal networks and thermal storage, and they could optimize the operation of the nuclear plant to be more profitable and more efficient, increase the efficiency from 25 or 30 to 80 or 90%, possibly make more money. And the big thing is that if we can avoid by having thermal networks to serve thermal loads instead of doing it electrically, we could massively reduce the expansion required of our electricity grids and our generating stations, local distribution, and even house services. And that's the message we're working on right now. And I think we're going to make it. So, if the consequences of this introduction is my sell to you, this would give us an unprecedented reduction in GHGs. Okay? We're looking at the government has policies. Oh, you electrify, the load's too high. Okay, we'll do high level retrofits. This is not happening at the rate at which it's required. We're doing like 1% a year or something like that. And it's expensive. You could use that same money much more effectively. So then the next is a lot of our new smaller reactors that are potentially more flexible in size, location, and everything else. If you had a revenue for the heat, right now they're too expensive. They're 15,000 a kilowatt hour or more. Now, if you have heat revenue, then it's possible that we could move up the feasibility of these MMRs and SMRs so that you could get things doing. The expansion of electric generation here in Ottawa, Bryce Conrad, CEO of Hydro Ottawa, has said, look, guys, we are facing, this was in the newspaper several months ago, we are facing historic investments to cope with the soaring electricity demand. and the price increases is going to be more than our customers can pay. So somebody else is going to have to cough up. Oh, somebody else is also the electric customers. So we're going to get it in the neck, whichever way goes ahead. Okay. So as I mentioned, generation efficiency could go way up. But the important thing I'd like to say to you is right now, this nuclear thing is the catalyst that's generating some interest and discussion. Both Boltzmann and the Ontario Society of Professional Engineers were making thermal networks as a focus of our interaction with the Minister of Energy this year. Uh, but if you had these thermal networks, then renewable energy waste heat utilization could go way up, right? Uh, Solar thermal that is only meeting some domestic hot water these days, if you could store all the high output in the summer, then you could use it during the winter and displace winter heating loads. So that's a big plus. So this is not just nuclear sale; it's a pitch to the renewable energy waste heat recovery people who want to have more efficient society. Um, the last is if you can have this beneficial impact on the electric system, we can probably keep electricity prices down much lower. So you will have this, but I just want to show you there's resources available on Boltzmann Institute. We've got an executive summary available on that website, uh, and the whole two pathways report we've put on an international website that stores such things, and this will be available to you all. Um, so, in conclusion, I just wanted to say what business does or should the nuclear industry be in? And secondly, what business does Canada or the world want the nuclear industry to be in? And the electric industries, obviously. Anyhow, well, thank you very much for your time. I hope that gave you some insight into what we're working on and what we're finding. And I'd welcome any questions.